Doo-doo-doo. Hello. Okay. Looks like my camera is hidden somewhere. Well, that's unfortunate. Or maybe it's not even plugged in and that might be the Rift camera. Regardless, that's not the important thing. This is the important thing. Okay. So what have I got here? I've got code for some magnetic encoders. And if I want, I can go to my Google Photos and pull up a nice picture of that. And let me see here what's on the Hangout window. I'll put the Hangout window over there. And then, oops. Okay. So these are what I'm working on. I've got some magnetic encoders here, and I need to get them to work. And this is some code that somebody provided on a forum for making these encoders work one at a time. Now, I already changed something. This was taking in the first 10 bits instead of 12 bits. And from all appearances, we need 12 bits looking at the sheet here. These, I believe, are for the 45B, which is the chip that I have. Oop. Okay. 45. Maybe that was the wrong one. Nope, not that one. Go back to Mauser and pull up the right spec sheet. 45B, 45B product sheet. Okay, 45B. And if we go down and we look at daisy chain mode, and I may have gone too far. And going back up. We see 12 bits, 0 through 11 for angular position data, and 6 bits for the status bit, and then we go on out. Now, my theory is this person only wanted the first 10 bits because, let's go to scientific view. Okay. If we take 10 bits, 2 to the 10, oh, that goes 1024. Okay, that busts my theory right there. Because I was thinking maybe they wanted to only get 360. Oh, wait. 10, 5, 6, 7, 8. But regardless, there's 12 bits. I should probably close some stuff for now. I don't need EagleCAD. And my wheel is constantly spinning. What's causing all the CPU usage? Okay, hopefully it goes down. Okay, so there's 12 bits with position info, not 10. There's 6 bits containing status info. If I look at this sheet, I should probably close the one for the hide. Okay. Okay, so if I look here, oh, that's where the other one went to. Okay, don't need that one. I see OCF. That's that one. COF, LIN. Basically all the magnetic error data here. Printing error codes. Short delay, long delay. So we set up all our pins on our chip. Short delay. Okay, so in a loop, we start by putting the chip select to high. We set the clock to high. So that's going to get us our data. Time between readers, signal start transfer with LED. We turn on the LED. We put the chip select to low so that we can actually start the transfer of the data out of there. Delay for chip initialization. Clock goes to low, start clocking. Hold low, clock signal 16. Transitions go to clock pin. Digital write the clock pin to high. We have a short delay. Read one bit of data. Left shift summing variable. Add pin value. Short delay, end of clock cycle. Okay, so since I changed that, it's no longer 16, it's 18. And I should probably test just one encoder by itself. Let's make sure there's nothing else. So we finish the transfer and we write the LED to low. Angle the packet, the pack data, which we got up here by shifting everything in from the stream, now gets ANDed with the angle mask. So all of the angle mask zeros, or all these, will actually contain data, I think. And these are all ones, so when, oh, no. If this, oh, my bad. Okay, all the ones with zeros, since it's an AND operation, obviously they're gonna get like, oh, that makes a lot more sense. So I was sitting there going like, what? That does make sense. Okay, yeah. And they get ANDed with zeros. Obviously, it's going to always be false because it's the zero. It gets ANDed with one, and then the data is true. You keep it. So we're just going to generate like a long or something down here by ANDing that together, which it chooses our angle. And then we shift 16-digit angle right 6 digits to form 10-digit value. Okay. I'm not completely sure why they shifted it after. And then the angle equals angle times 360 by 1024. Actually, that may be the number we pulled up earlier. Yes, it is. So since I now changed it to 12 bits of information, this number right here is going to have to change. So go back into programmer mode, and we will take a decimal. Oh wait, no, we can go back in the scientific. 2 to the 12 now, instead of 2 to the 10. 4096. Edit, copy, clear. And we can take 360 and divide it by our new value, 4096. And that will get us our new value. And we can paste that in. Now, this might still be doing something funny, so I hope not. Oh, wait, no, shift it. That's just shifting out the bits on the end, so that should still be fine. Then we print an angle, and we print angle as a decimal value in the serial readout. And then if debug, then it's going to handle all the stuff with the status bits. Currently, I don't think we need to worry about that. So what I'm going to do now is switch over to holding in the teensy with the magnet. So I'm going to upload this code and go into the serial monitor and make sure I didn't just break everything by adding in the extra bits. USB-based request to automatically reboot. Please program button or teensy to upload your sketch. Oh, that would be a problem, yes. I was using the cable for my phone. Thankfully, I don't think the Arduino program tried to program my phone. Yeah, it would be quite an overkill using a phone to run this real-time application. And COM port 3. Okay. Let's try uploading that again. Now if I open the serial monitor and actually stick the magnetic to here, I am still getting 0. That is not good. I broke it. Oh, wait a second. Let me try unplugging and replugging the header pins, as that sometimes resolves it. No, maybe not this time. Try rebooting the teensy. And redoing the serial. It's still not. It's not recognizing the teensy. Okay. Should be reading 0 right now because the teensy is not plugged in, or the sensor's not plugged into the teensy. Rather, plug the sensor back into the teensy. And I'm still not reading anything. Okay. I believe my baud rate is correct. 9600 clock. Okay. So either this is not right, or I missed something in the code. It's just six bits. Let's try. Well, I could shift everything back, but I don't want to do that right now, just in case. Let me just try one other thing. I'm going to try plugging it into the other sensor. Because thankfully I have multiple of these. Oh no, that was interesting. Looks more like a case of a loose cable than anything. Okay. Okay. One of these pins is doing weird stuff or picking up noise or something. So if I unplug it and I plug it back in. See, any time I unplug it, it should be getting me a 0, but it's not. It's perhaps one of the more disturbing things. Is that it's not doing that. No, the magnet did not lose its magnetism. Okay. Now, if I go back to the original code, file, save as, let's say this as 18-bit encoder read for now. Okay, so I'll go ahead and put back the original code because I got this saved, so I don't have to worry about losing it. Yes, I believe this is it. So I'll save put in this other one, call it 10-bit encoder read, and hopefully it's right. Okay. Uploading. So I unplugged it and replugged it. And now it's reading again. So it seems to like this 10-bit version, but not the other 12 when we add the extra 2 bits. So I wonder if there's an explanation for that. In here somewhere. Okay. And pin 9, serial connection. All connected devices is read from DO pin, the first device in the chain. Length of serial bit stream increases with every connected device. N times 18 plus 1. 1 bit, yeah, between each one, which is this one right here. But why, oh why, does it seem to be making a liar out of that and doing 16? So I'm going to save this as 16-bit. And then open back up the 18-bit. And make sure that it still has my code from before, which it looks like it does. And re-upload that and see if I get anything different now. And now it's reading with 18 bits. So that was weird. Maybe. Well, no, I uploaded this code already and it didn't work, and I uploaded it again and now it's working. So it's very weird. But yes, that was kind of necessary. Need these 18 bits. So now I need to adjust the code. So first it gets an input stream. The input stream goes into pack data. It gets shifted into pack data. And then after we do all that, we're great. But if we're reading more, then we need to shift more into pack data and possibly have multiple angle masks, because we've got need to have like a joint angle 1, joint angle 2, joint angle 3, etc., etc. So I'm going to go ahead and kill the teensy off for now while I rework some of this code. Okay, so I'm gonna see if this has the ability to find and replace all. We'll replace all current instances of angle with bot point angle 1. Okay. That didn't seem to work. Let me control Z and try that again. Okay, let's see how that did. Arduino's refactoring may or may not be. Oh, jolly. Joint angle 1 mask. Okay, so right now I'm just reading for 2 joints. So we need a letter long robot joint angle 2 equals 0. So that's our current one. Now this mask is going to need to be much longer. So we need to add in this many zeros. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, plus 1 for that in between. Then, oh, no. She's more than that. We have, let's start from the end. So we've finished our one, and then we do 1, and then we have to put in another 18 bits of zeros. So that's should all be fine. And we got our 1, 2, 3, 4, 5, 6 status bits. We have our 1 bit of transition. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Wait. Yep. 17, 18. So that should be good now as a mask. And, oh, no, I don't want to be opening Unity. Close Unity. Okay. Calculator to programmer mode. Binary, edit, paste. So we've got that. We transfer it to decimal. We copy it, and now we've got our mask for angle 1. Oh, okay. Put a robot joint angle 2 mask equals. So now I'll copy this, modify. For the first 12 digits. Not completely true. Well, it's the second 12 digits that actually have position data. So let's leave that there for now. So I can do 1, 2, 3, 4, 5, 6. Then at bit. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Should leave 6 left, which it does. So we put 12 back in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's gone back to the same length. And we just add zeros until it puts the colon back in the same place. We go back over to our calculator, switch back to binary, clear everything, edit, paste. No, that's not right. Copy, edit, paste. That's right. Okay, so we transfer that over into decimal. We've got our new value. Copy. Okay, so that's mask for that one. This is the mask for the second joint angle. Now we need to worry about the status mask. Right now, I'm not sure if I really care too much about the status mask. It's fine. We'll go ahead and just take care of it anyways in case we need it later. So basically, we've got that, and then we've got the one for in between. Then we've got 1, 2, 3, 4, 5, 6, 7, 8. Actually, line these up. It'll make it easier. Oop. Okay. That's our status number 1. Status mask number 1. Oh, wait, I should get rid of that. Binary, edit, paste, convert it back to decimal, copy. So this is our new status mask. Then I need a long status mask 2 equals, like, you can just kind of copy this. Change the last 6, 1, 2, 3, 4, 5, 6 to ones, and then put these back to zeros. Okay. So now we've got our mask number 2. Decimal. So now this one's what that one was before, 63. Okay. So, all right, at least I can get close that. Okay, so now we have total of 18 times 2 plus 1. 18 times 2 plus 1. 37 bits each iteration. So we need to shift in 37 bits right here. Then we iterate 37 times. We come out of the loop. And then for robot joint angle 1, we put with that. There's a lot of extra stuff here that they left commented out. I'm not sure if we will end up needing in the end. Joint angle 2 equals data and robot joint angle 2 mask. I believe is right. Yes. And then just like this one. Oh no, snap. Okay. So this one is now shifted by way more than 6 bits. This one needs to be shifted by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, 25. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 5. Okay. 25. And this one by 6. And after we've shifted it, the multiplication down here should be about the same. Okay. Then we serial print line about joint angle 1. And then we should print. Oh, I'm still not doing it right. Okay. Print. I wonder if I could put a tab. Paul, \T, right, for tab?
What? I guess.
Yeah. Tab symbol programming. \T. It's the escape code?
Backspace is an escape character. And if it's tab.
Oh, the escape code is \T. Most likely.
Yeah.
Okay. Okay. \T. I want to change this to just a print. We put a \T before printing joint angle 2. And then this one can be a print line. Obot joint angle 2 in a decimal form. Debug's probably set to false, right? Yeah, debug set to false. So all this stuff down here just completely gets skipped over. Pec data gets reset. Robot joint angle gets reset. And we need to make sure that our joint angle 2 also gets reset. So they're not accumulating, they're starting from scratch. Ooh, okay. It's not liking something there. My English. Okay. So presuming we did everything right, it should now be able to read out. Oh, there's one other thing I should do. Otherwise, this is going to throw up on me. Is I need to actually have a second sensor hooked in. Otherwise, it's going to be getting the data all funky. Okay. Let's re-upload that just to be sure. Let's try again. I pushed the reboot button. Oh, that's right. I had unplugged the Teensy again, so Okay. Uploading sketch. Beep. Beep boop. Okay. One of them is always getting 0 and the other one is getting 359. Oh, that's not exactly what we wanted. Nope. Pulse like, nope. Which is not what we want at all.
I'm assuming we are the one freaking.
Okay. Whee! Okay. Am I affecting either of these? No, it doesn't appear as though I am. My bit shifting is gone mad. Bit shift. Have you any wool?
Well, come on.
Me neither. I would like to upload you one more time and see if that has any difference. This really disconcerting thing is I'm getting some negative values. Oh, interesting. I think this one is actually reading out the second encoder just fine. It's the first encoder that's having issues. It's like in negative values. So I probably programmed something bad. Well, that's fine. We can go tinker back through the code and find out what went wrong. Okay. Let's see what we did. What's the damage?
3.21 gigawatts.
Oh dear. So where's that document? N times 18 plus 1 bits. Oh, is there another bit? I mean, that wouldn't really make any sense, though. I mean, because the last one, you don't really care. You can discard that last bit, I would think. Let me just calculate. We've got 18 times 2 plus 1 equals 37, right? Yeah, so it's decimal. That looks right. That's the mask for that one. These don't ever really get used. And we iterate through 37 clock cycles, shifting data in. We get the PEC data with the mask. we shift this one by 25. Is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 16, 17, 18, 19, 20, 21, 25. Yeah, it looks right. Oh, wait. Is it right, though? Yeah. 25 bits. We shift it. We only need to shift this one by 6 because it's right towards the end. We say this one's this times this one's this times this. We print out the joint angle 1 in decimal. We print out the joint angle 2 in decimal. Okay, let's try that one more time. But presuming the error returns, maybe I'll have to consider what they said about the iterations, though it doesn't seem very probable. The second one's still reading fine. The second one's still negative values. But it does seem to be affected by the magnet. Okay. Now, what would cause it to become a negative value?
Negative rotation.
What, Paul?
Negative rotation.
Negative rotation. No, that shouldn't be it. I'm wondering if I was shifting it too far.
Oh, what if it's actually like an unsigned int or something like that, but you're reading it as a signed int?
What am I shifting into? I'm shifting into pack data, and pack data is a long.
Okay, but is it signed or unsigned?
Number of bits long. A long is probably 32 bits.
So it doesn't matter, I'm betting. At least it's better than that.
Wait, this might be exactly 32 bits. Oh, snap. Yeah, that could be a problem. Does Arduino support double? It looks like it does. I might have to use doubles. Or at least a double. Is that gonna? Yeah, that's gonna throw up.
Your computer's going to fill up.
The compiler is.
That's fine.
I think I'm gonna might need to replace all these longs with doubles, unfortunately. Uh, Control Z. Uh, uh, Maybe it's just the way that decimal outputs it. Or maybe I shouldn't be trying to put this much into one input stream, the PEC data. Okay. So this is what I think I'm going to do. I'm going to go back in time. Just kidding.
Speaking of which, that's actually a security problem for some computers. They figured out how to change the input coming in when they check online. You know, the everybody's clock thing. Sometimes they'll use old security stuff. That's temporary.
Well, I think I need another 2 bytes concatenated from input stream. Okay, so we need pack data and pack data 2. And then get rid of that. We'll just use the original angle mask. And the original status mask. And get rid of the new one. And then what we'll do is we'll just control it in the loop such that we get 2 pack datas. And then, yeah, we'll apply the masks to each of them to get the joint angles. That sounds reasonable. So I'll need to put these back to the original values. Copy. Coffee. Not allowed. Okay. I love coffee. 63. That's right. 63. Brilliant. Okay, so now we're back to original joint angle and our original joint angle mask. We've got two sets of packed data. So we need to do some conditionals on this loop right here. The 6. Okay. So if we are less than, oh, I think I should just open up the other one so that I can view. Oh, wait, no, this one isn't completely right either. If we are less than, I think it's 18, it would be right. X is less than 18, then wait, we write high, we delay microseconds, we get this. Where's the pack data? Here we go. If X is less than 18, then pack data gets the data. And then we do a write low, we do a short delay, and we do it again. But if X is greater than 18, because we don't want to read it on 18 because that's the transition bit. And also, oh, yeah, if it's greater than 18, that's the only condition we need, then pack data 2 gets everything. That makes it nice and simple. Okay. Pack data 2 gets the input stream. And then after we pack data 2 gets the input stream, then joint angle 1 equals the robot joint angle mask. And otherwise, yeah, and then joint angle 2 gets pack data 2 and that. Then this one only needs to get shifted by 6 bits instead of that many bits. They both get multiplied. And I think that's all we needed. This a different way of thinking about the problem due to bit size limitations. Oh, jolly good. I have 2 joint angles. Now I am controlling the left one with this, and wait a second. Wait, is this one not actually working now? Now joint angle 1 is working, but joint angle 2 is not working. Ah, not fun. Okay, well, I can look at the code some more. Actually, I'll probably just re-upload just to make sure for messing around with the code when it might just be it was off a little bit. Okay. Nope. This one's pretty much staying about the same. So I'm going to take a look at the code again. We're getting close, though. Okay. Oh, well, I think I'm getting close, but... Oh, okay. Well, LED pin 13, clock pin 7. Input stream gets 0. Pack data 0. Pack data 2 equals 0. We have masks. That should be working fine. We go into a loop. That could be an issue. Pack data wasn't getting back data to shifted on input stream plus input stream. Okay. Yeah, I think a quick review before loading it last time and we would have seen that. Okay. Okay. Now let's try it. This one's working. This one's working. And yes, so now I could probably clean up the code a little bit, but for the most part, we have this. Now on the final robot arm, there'll be 6. So basically what I would need to do is add 4 more joint angles and then or pack data and then a few other variables and we'd be reading just fine. So I think that's where I'm gonna stop this this recording. I'll catch everyone later. Goodbye.
In case you're wondering, they made a sequel to Wind Waker and spliced this in music.
Oh, stop.